Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The starting material is 3,3-dimethyl, 1-butanol, CH3-C, CH2-CH2O. Moving on to the next step. Oxidation with K to Cr2O7H2SO4H2O heat. The primary alcohol, CH2CH2O, is oxidized to a carboxylic acid, CH2CO, since K2Cr2O7 in acidic aqueous conditions with heat oxidize primary alcohols all the way to carboxylic acids. So A is equal to CH3-C, CH2CO, 3,3-dimethylbutanoic acid. Moving on to the next step. Reaction with SOCl2. SOCl2 converts the carboxylic acid to an acid chloride. So B is equal to CH3-C, CH2COCl, 3,3-dimethylbutanol chloride. And for the final step. Reaction with CH3-NH, 2 moles. Dimethylamine reacts with the acid chloride to form an amide, with the second mole of amine acting as a base to neutralize the HCl produced. So C is equal to CH3-C, CH2-CO-N, CH3-N, N-dimethyl, 3,3-dimethylbutanamide. Reduction with Lyl4 in diethyl ether, then H2O cup. Lyl4 reduces an amide to an amine. The C is equal to O of the amide is reduced to CH2, giving CH3-C, CH2-CH2-N, CH3-2. This is CH3-C, CH3, CH3, CH2-CH2-N, CH3-2, which matches option B, CH3-C, CH2-CH2-N, CH3, with CH3 groups above and below the quaternary carbon. Why other options fail? Option A contains a nitrile group, which is not formed in this sequence. Option C has N, CH3, 2 on a secondary carbon adjacent to the quaternary carbon, which would require a different reaction pathway. Option D has both N, CH3, 2 and O on the same carbon, which is not the product of amide reduction. Therefore, the correct answer is B. Therefore, the correct answer is option B.